components, its types, and the assessment, and also the energy efficiency. And we are going also to show the design calculations. Here are my group mates, RR, Ian, si Kuya Lauren, at saka si Ed. Then, ibigay ko po yung floor kay RR.
So, first, we must get to know what is cooling tower all about. So, cooling tower is equipment used to cool heat, to cool water that is used for heat exchange, mostly in heat exchange for as a recycle for another process. So, cool tower needs to water extract. It includes it is an equipment that reduces temperature of water by extracting heat from water and heating into the atmosphere. So, the components of cooling tower, first there are frames, and casing, field, and then cold water basin. These are the main components of cooling tower. The three filtrators, the air inlet, the loopers, nozzles, and fans. Can you go back? So first, the frames and casing. These are the exterior part of the cooling tower. It can be steel or it can be concrete. So steel type or the wood type can be built, can be a factory built, but the cement type, the ones that we used to know, like in nuclear power plants, the one which is hyperbolic type, it is a site erected, but those type of cooling tower are most recommended for large industries since it is expensive. Next, there is two types of field, the splash field and film field. So, the splash field is a horizontal splash bars which continuously breaks the water into small droplets as it passes through the fields. This can be plastic type or wood type, but it is mostly recommended to be a plastic type since it maximizes the heat exchange between the air and the water. Next is the film field, which is a closely spaced plastic surfaces in which water spreads and forms film that covers the field. So, in that sense, it maximizes the heat exchange more than that of the droplet of splash field. So, film field are more efficient than splash field. Next, the cold water basin. It receives water at the bottom of the tower. So, it is located near the bottom of the tower, and the forced drop type of cooling tower, it is channeled to a perimeter since in the forced drop counterflow there is the use of fans beneath the cooling tower. Next is the draft eliminator. It captures H2O, which is entrapped in the air that is excreted by the cooling tower. So it is used to recover that loss. It is used to recover the lost water that is in the air evaporated through the process. Next is the air inlet. It is the entry of air, and it is usually located at the bottom of the tower. And next is the loopers. These are used in cross-flow design, but in counterflow designs of cooling tower, it's not usually seen. The nozzles are sprays which sprays water into the field, so it facilitates the uniform distribution of the water towards the fields. And next is the fans. These are used for mechanical cooling towers. So there are centrifugal and draft fans. Propeller uses draft towers, while propeller and centrifugal fans are for forced draft towers. So there are types of cooling towers. First, the natural draft cooling towers. This involves there is no use of the fan since it is governed by the difference in temperature of the ambient air and the hot air inside the cooling tower. So as the hot air in the cooling tower, since it is more less denser, it tends to go outside the tower in a upward manner, while the ambient air, which is cooler than the inside temperature of the cooling tower, is drawn into the tower from the bottom. So mostly, the most common type that we've seen is the one with this concrete one. So these are the most common type of the cooling tower, which is used as an example. So these are the hyperbolic ones. So that one, as mentioned earlier, are used for large scales industries. So next is the two types of natural draft cooling tower. First is the cross-flow cooling tower. So this is the cross-flow cooling tower, and then the other one is the counter-flow cooling tower. So what's the difference? So the difference is that cross-flow tower, air is drawn across falling water and fill are located outside the tower. So in the cross-flow cooling tower, there's the use of louvers, which facilitates to equalize the distribution of air towards the film and also the water. So the air, the ambient air enters this way, while these are the fields, the one outside the tower, and in counterflow natural draft tower, there's the fields are located inside the tower, which is here, and there's an inlet below the tower in which the ambient air is drawn. Next, and the other type of cooling towers, the mechanical draft cooling towers, which uses fans. So large fans force air through circulated water. Water falls over field surfaces, which maximize the heat transfer between the water and the air. And cooling rates depend on many parameters like fan diameter, speed of operation, and field persistent resistance. Next, there are three types of mechanical draft cooling tower, which is the forced draft, induced draft, cross flow, and induced draft counter flow. So let's discuss. First is the forced draft cooling tower, in which air is blown through the tower by centrifugal fan and the air inlet. So this is the fan, and the advantage of this is that it's suited for high air resistance and fans are relatively wide. So it's wide since it is inside the tower, and then suited for high air resistance since it is a centrifugal fan, and then it is located here. So there is there is no corrosion that will occur for the fans.